Okay, today we're going to look at section 5.1, systems of linear equations. This is the last section we cover. So you'll be taking test 4 after this, and then eventually taking your final exam. So here we're going to learn how to solve systems of equations two ways. We're going to learn the substitution method and the elimination method, which is sometimes called the addition method. So first we have to look at something. An ordered pair is a solution of a system of equations if it solves both equations. So let's determine if -3, -5 is the solution for the systems of equations. So we have two equations here. Somehow they got jammed together. So we simply plug in the values. 4 times -3 minus 2 times -5. And does that equal -2? 4 times -3 is -12. -2 times -5 is +10, and it does equal -2. So far, so good. Now we have 3 times -3 plus 2 times -5 equals -19. That's -9 minus 10 equals -19, and that is, so it is a solution. So let's look at our substitution method. So for the substitution method, the first thing we do is solve one of the equations for one variable. It doesn't matter which variable in which equation. We substitute this into the other equation to get an equation in one variable, solve for that variable, and then solve for the other variable. So we have a system of equations here. 2x minus 3y equals 2, and y equals 5x minus 18. Using substitution, I would probably solve for y since it's already done. So we take this value here for y, and we plug it into here. And now I have 2x minus 3 times 5x minus 18 equals 2. I have 2x, -3 times -5x, or -3 times 5x is -15x. -3 times -18 is plus 54 equals 2. So I combine my like terms here, -13x. I subtract 54 from both sides and get -52. Divide by -13, I get x equals 4. So now I take this x equals 4 here and plug it in here. So I have y equals 5 times 4 minus 18. 20 minus 18, y equals 2. So my ordered pair is 4, 2. Now, here's the interesting thing about this. We can check our answers on this. Real simple. Plug it in the first equation. 2 times 4 minus 3 times 2. Does that equal 2? 8 minus 6 equals 2. Yes. Does 2 equal 5 times 4 minus 18? Does 2 equal 20 minus 18? It does. So that is a solution. Okay, again, solving for substitution. We can solve for either variable in either equation. I'm looking here at y again. So let's take this. 15x minus 5y equals -10. So let's subtract 15x from both sides. -5y equals -15x minus 10. Divide by -5 and I get y equals 3x plus 2. Okay, So now put this in here. I get 3x plus 2 times 3x plus 2 equals -7. 3x plus 6x plus 4 equals -7. So I have 9x equals -11. So x equals -11 over 9. Plug that in here. 3 times -11 over 9 plus 2, which is 18 over 9. I have -33 over 9 plus 18 over 9, not 2. So I get -15 over 9. So my point, -11 over 9 minus -15 over 9. And again, you can check it. It's a little more complex, but it can be checked. Okay, so let's look at another one here. Again, these formulas are not showing up where the way they should. These are typically written one above the other, like this. So substitution, again, I'm looking at this 2y here and I'm thinking 2y equals 4x plus 2, y equals 2x plus 1. Plug it in here and I get -6x plus 3 times 2x plus 1 equals 3. Now -6x plus 6x plus 3 equals 3. Combining these common terms, I get 0 and I end up with 3 equals 3. Now this is an interesting concept. What's happened here is for every value of x and y, this is going to be true. So we have an infinite number of solutions. And let's play with this a little bit. Let's look at this 2y minus 4x equals 2. What if I multiply both sides by 3 halves? I can do that, right? Well, here I would get 3y minus 6x equals 3. The lines are the same thing. That's why they have infinite solutions. The point a line has in common with itself is every point on the line. So this brings us to the elimination method. Again, sometimes called addition, and you'll see why in a moment. We want to eliminate one of the variables and solve for the variable in the resulting equation, and then solve for the other variable. So what I want to do, and let's rewrite these this way. 4x minus 3y equals -13, and 5x plus 6y equal to 13. What I want to do is manipulate one or both of these equations till the values, the constants for one of the variables are opposites. So I'm looking at this. If I multiply this equation by 2 on both sides, I get 8x minus 6y equals -26. Bringing my other equation over, plus 6y equals 13. Now, when I add these two equations, I get 13x. The y's are eliminated. -13. X equals -1. Now I can plug that into either of these equations. I'll go here. 4 times negative 1 minus 3y equals negative 13. Negative 4 minus 3y equals negative 13. Adding 4 to both sides, I get negative 3y equals negative 9. Y equals negative 3. So again, I had the point negative 1, negative 3. And you can test this by plugging it in to both equations. Okay, now we have a little more complex. Let's look. 2x plus 4y equals 8. So what if I take the top equation and multiply by negative 2? I get negative 6x minus 6y equals negative 10. And if I multiply this equation by 3, I get 6x plus 12y equals 24. Now when I add, I get 6y equals 14. Y equals 14 over 6. So now going back to the original equation here, and I'm going to use this one. I have 3x plus 3 plus 3 times 14 over 6 equals 5. I have 3x plus, is this 14 halves equals 5. And we'll call this, what, 10 halves? Okay, so then I subtract the 14 halves. I get 3x equals negative 4 halves, which is negative 2. So x equals negative 2/3. I have 14 over 6, negative 2/3. Again, you can always test these and see. Okay. So here I have negative 5x plus y equals 7. If I take this, multiply it by negative 2, and I'm going to rewrite these over here, bring this one over the same way. Multiply this by negative 2, I get 10x minus 2y equals negative 14. Adding, I get 0 plus 0 equals 12. Well, that's never true, so there are no solutions. So we can look at these while we're here. I have 2y equals 10x plus 26. I'm looking at this first one here. Y equals 5x plus 13. And here I have y equals 5x plus 7. Note the slope is the same, but the intercepts are different. So these lines are parallel, which means they do not intersect. Which brings us to this. What do you think the solution would be if the lines were parallel? There would be no solution. If the lines are the same, well, there would be infinite solutions. And we looked at both of those. Here we had parallel. Where was that other one? And here we had the same line. So again, the solution to the system of equations is the point where the two lines intersect. That is it. that is it for lectures. I guess it wanted me to find this point here, which is -2, -3. That is the last of these lectures. As far as the individual sections go, there may be something put up later as far as a review for a final exam. But really, your best review for the final exam will be the exams. So that's all I have today. Have a good evening and take care.